same charge.
The same charges repels while the opposite charges attract. The forces between charges weakens with distance. A French guy named Charles Augustin de Coulomb came up with a bright idea to measure forces between distance.
Coulomb's first finding was that the size of the electrostatic force is directly proportional to the product of the magnitude of the charges. So Coulomb's first finding simply means that the bigger the magnitude, the bigger the force between them. Coulomb's second finding was the electrostatic force is inversely proportional to the square of the distance separating the charges. And Coulomb's second finding simply means that the farther apart, the weaker the force between them. Now, since we have understand about the Coulomb's finding, let's try and transform these words into mathematical equations. So, the magnitude of the charges is denoted by letter Q, and K is the Coulomb's constant, which is the value 8.99 times 10 raised to 9 Newton meter squared over Coulomb negative squared. And the distance separating the charges is denoted by letter R. In summary of Coulomb's finding, he came up with a formula which is F is equals to Coulomb's constant times the product of two charges over the distance squared. And finally, time for examples so that we can understand well the concept of Coulomb's law.
The two charges magnitude of 3.8 times 10 raised to the power of negative 17 coulomb and 1.8 times 10 raised to the power of negative 17 coulomb with a distance of 150 nanometer. What is the electrostatic force by each charge? First charge is equal to 3.8 times 10 raised to the power of negative 17 coulomb. Second charge is equal to 1.8 times 10 raised to the power of negative 17 coulomb. And the distance is equal to 150 nanometer. So we will convert it to meter. So 150 times 10 raised to the power of negative 9. Coulomb's constant is equal to 8.99 times 10 raised to the power of positive 9 Newton meter squared times Coulomb to the power of electrostatic force equals to 8.99 times 10 raised to the power of 9 Newton meter squared times Coulomb to the power of negative 2 times 3.8 times 10 raised to the power of negative 17 Coulomb times 1.8 times 10 raised to the power of negative 17 Coulomb over 150 times 10 raised to the power of negative 9 meter squared. So the calculated value is equal to 2.73 times 10 raised to the power of negative 10 Newton.
Example number 2. What is the magnitude of the force between a 2 nanocoulomb charge and a negative 3 nanocoulomb charge separated by 3 millimeters? As we all know, the formula of the static force equals Coulomb's constant, the product of two charges over distance squared. Given the values, K equals 8.99 times 10 to the power of 9 Newton meter squared over Coulomb's negative 2. Q1, 2 times 10 to the power of negative 9 coulomb. Q2, negative 3 times 10 to the power of negative 9 coulomb. Distance equals 3 times 10 to the power of 3 meters. From the formula, we directly substitute the given values. F equals K 8.99 times 10 to the power of 9 Newton meter squared over Coulomb's negative squared times the first charge 2 times 10 to the power of negative 9 coulomb times negative 3 times 10 to the power of 9 coulomb over the distance 3 times 10 to the power of negative 3 meter squared equals negative 6 times 10 to the power of Newton.